Okay, very quickly. How do we prove this trigonometric identity? First, we recall the identity that tan A minus B is equal to tan A minus tan B all over 1 plus tan A tan B. Then that means that if A is pi over 4 and B is theta over 2, we're going to get that tan pi over 4 minus theta over 2 is equal to tan pi over 4 minus tan theta over 2 all over 1 plus tan pi over 4 tan theta over 2. But of course, we know that tan pi over 4 is equal to 1. So we have 1 minus tan theta over 2 over 1 plus tan theta over 2. Also, we recollect that tan x is equal to sine x over cos x. Therefore, this becomes 1 minus sine theta over 2 over cos theta over 2 all over 1 plus sine theta over 2 over cos theta over 2. So let x be equals to theta over 2 so that we are going to make it as compact as possible. So if we simplify the fraction here, we have cos x minus sine x over cos x divided by cos x plus sine x all over cos x, and that gives us cos x minus sine x over cos x plus sine x. But this is just tangent, and the identity we need to prove, that is the square of this expression. Therefore, the left-hand side of the expression, which is tan squared pi over 4 minus theta over 2, will be the square of what we've gotten. So, but we shouldn't forget that x is now theta over 2. So this is going to be cos x minus sine x squared over cos x plus sine x squared. And this expands to give cos squared x minus 2 sine x cos x plus sine squared x all over cos squared x plus 2 sine x cos x plus sine squared x. And we know that cos squared x plus sine squared x is equal to 1. So it affects both the numerator and the denominator. Also, we know that 2 sine x cos x is sine 2x. So this gives us 1 minus sine 2x over 1 plus sine 2x. Then finally, we recall that we set x to be equal to theta over 2. Therefore, this, our left-hand side, will be equal to 1 minus sine 2 times theta over 2 over 1 plus sine 2 times theta over 2, which is exactly equal to 1 minus sine theta over 1 plus sine theta, which is the right-hand side that we wanted to show. Thank you.